Hello everyone, I am Sonali. In this video, you will learn third type of control structure, loop. In previous video, we had learned the sequential control, decision making control or condition control. In this decision making control, we had learned if else means the compound if else and nested if else. Now we will move towards the loop. Control structure in C. In this, we will learn first for loop. In a loop control, there are actually the three types: for loop, while loop, and do while loop. Okay, we will learn first for loop. Why we are using actually the loop to execute some specific part of a program, number of times we will use the loop. Okay, here are the different types from which we will learn first the for loop. The syntax of for loop is for, then initialization. Okay, here is your initial condition. Okay, then condition. This is your condition. And third part is increment or decrement. You can increment the value of variable or you can decrement the value of variable. And after this for, here is you can write the set of instruction block of code inside this curly bracket. If only one statement after this, no need to do this curly brackets. You can change this syntax as, you can write this syntax as first initialization, then for, inside this semicolon, then condition, again semicolon and one more part. Okay, you can write here increment or decrement. But the three parts is necessary: initialization, condition and increment decrement. Okay. Here you can use the pre or post increment. See, in increment you can use the pre or post. Similarly, like in a decrement, you can pre-increment or you can use the post. Okay. What is actually the difference between the pre and post? Okay, when you are pre-incrementing the value of variable, at that time it returns the value of increment operation. Okay, and when you are using the postfix or post increment, it returns the current value of the expression. Let's see the simple example for increment and decrement for the prefix and postfix working. Okay, here is a hash include stdio.h. This is standard input output header file. This is conio.h. When you are using the turbo C, at that time it is name, but when you are using the red hat or other, no need to do this conio. Int main, int a equals to 5. See, value of a is initially 5. Then clear screen. After this printf, here we are printing this value of a. So our output is 5. Then printf, here %d, then a plus plus. When we are using this post increment, at that time the current value of this variable will print. So here is the output 5 again. But it incrementing the value of this variable by 1 after this printing of the value a. Okay. Then printf %d plus plus a. So plus plus a. Here is the value of a is 6 now. Then consider this value 6 and then plus 1. So here is output 7. So what will we get the output? Here we will get 5. Here also 5 and here value 7. Let's see some examples of the for loop using the turbo C. See, here is a one simple example to print the number from 1 to 10. So first use your header files, then void main. I am using here void main. You can use the int main also, but when you are using here the int, at that time it is necessary to give the return 0. Int I, then clr str, clear screen, to erase the previous program output. This is a function of conio.h. For I equals to 1. See, this is your initialization. I less than equals to 10. This is your condition. And I plus plus. This is your incrementation. Then print %d, I. Okay, first it will print the value of I equals to 1. It will check 1 is less than equals to 10. This is condition. If yes, then it prints the 1 here. If not, it will jump out of the loop. Okay, 1 is less than equals to 10. Yes, true. So print 1 here and here 1 plus plus. This is a post increment. So it will print the first current variable value, and then it will increment the value by 1. Then for the next step, I equals to 2. 2 less than equals to 10. Yes, correct. Print the 2. Okay, here 2 plus plus. Up to 9. Suppose I equals to 9. 9 less than equals to 10. Yes, true. Print the 9 here. 9 plus plus is 10. Again go to this. I equals to 10. 10 less than equals to, yes, here is the equals to sign. So 10 less than equals to 10, it print the 10 and then 10 plus plus. So I equals to 11. Go here again. I equals to 11. 11 less than equals to 10. No, false. So at that time, it will jump outside this bracket and here. And it will execute the remaining part of your program. Okay. Let's compile this program. Click on a compile and press the compile to compile this program. Then to run, click on a run and run this program. So output is 1 to 10. You can change it as you can view here the message here printf print numbers from 1 to 10. Okay, you can give this message. Okay, and also give the here /n to print the output on a new line. Check once again. Alt F9, Control F9 to run. See, here is now message print number from 1 to 10 and then 1 to 10 number. In this way, you can change only this number. If you want to number from 1 to 100, you can do. Okay, you can remove this /n and you can do the /t. So, what will be the output? Alt F9, then Control F9. See, now number in horizontal /t, only tab is here. Okay, so 1, 2, 3 up to 100. Here is your output. Okay, you can use here your condition making statement, means if. Okay, for 1 to 100, here you can give the condition like if your I mod 2 equals to 0. Okay, means suppose your number mod 2, if number is divisible by 2, the remainder is 0, then only print that. So let's check the answer. Okay, here is only even numbers between the 1 to 100. Here you can change the message print even numbers between 1 to 100. Okay, you can modify your program as per your requirement. Okay, why? If I mod 2 equals to 0, then print only this number. If you want only odd number, you can also do this. I mod 2 here not equals to 0. Okay, not equals to 0. Execute this program. For the odd numbers, I am changing this. Okay, so then Control F9. See, here is your all odd numbers between the 1 to 100. In this way, you can create the different programs with the help of this. Here you can specify the different conditions. Okay. Now let's see the another example. I have already typed some examples. So let's see this next one. Okay. Our next example is write a C program to print characters from A to Z. Okay. Here we are printing the alphabets from A to Z. This is small a to z, or suppose you want the numbers from 0 to 9, you can also print. Okay, here we are printing this 0 to 9 in the character forms. Okay, actually for all these alphabets and for all these numbers, here is a ASCII value. What is a ASCII value? ASCII stands for American Standard Coding for Information Interchange. Okay, here is a set of characters. For every character there is a number. Okay, so for A to Z, number is 65 to 90. Okay, this is a predefined number. For small a to z, 97 to 122. And for 0 to 9, 48 to 57. You can also check the characters and the related number of this character by using the for loop. Okay, here we will see first how to print A to Z. Okay. Here we are assigning I equals to 65 because we know that to print the character A, ASCII value of A is 65 and ASCII value of Z is 90. So I less than equals to 90 and I plus plus. Here we are printing the characters. So do the %C. Okay. I's character value. Okay. This I is a number. I's character value. So %C. Let's execute this program. Alt F9 to compile the program and Control F9 to run the program. See, here is your output A to Z. Okay. You can remove this /n and do the /t. So check once again, Alt F9, then Control F9. See, here is your output A to Z. Suppose you want the number also and character also, then do %C /t %t and here give I 2 times. So first I is for character. Okay, and second I is for integer. So let's check the output. See here, A 65, B 66, C 67. Okay, in this way you can check. After %d, you can do the /n. Okay, so let's check. Alt F9, Control F9. Okay, now here is alphabets and respected value of this ASCII value of the alphabet is in front of this alphabet. You can change here simply A is equals to 65 to A is equals to 97. And here you can check 122. Okay, 122. Now execute this program for the small letters A to Z. Here you can change the A to Z. Check once. Okay, here is the ASCII value, alphabet and ASCII value of this alphabet. You can change all these for I equals to 0 to 255. So you will get more information about this and I am removing this /n. Okay, remove this /n and check for this. See, here is first your number, then character value, number, character value, number, character value. Okay, in the 255. Here this 255, this character set covering all characters. Okay, you can check it and you can change this. After this, we will see the next program is how to calculate the factorial of number. Okay, how to calculate the factorial of number? See, when we are calculating the factorial of number, suppose 5 factorial, how to calculate is 5 factorial is 5 into 4 factorial. Okay, we are multiplying the number. Okay, 5 into 4 factorial. Then what is next step? Next step is we are calculating the 4 factorial. So 4 factorial equals to 4 into 3 factorial. Okay, in this way we are calculating the factorial of number. So means how to calculate the 5 factorial? 5 factorial equals to 5 into 4 into 3 into 2 into 1. Till 1 we are calculating the factorial. And 1's factorial is 1. We know that. Okay. So let's see the program for this. See, I am using here the multi-line comment because my comment is starting from this line to this. So at that time, it is necessary to use this type of comments only. If you are using the single line comment, then there will be the error. Okay. Hash include stdio.h, ponyo.h. Okay. Here we want the variable number. Okay. And for the number, to accept the number, to calculate the factorial, I is for the increment and fact. We are using this variable to store the factorial. Initially fact equals to, we are assigning 1. Okay. Printed. Enter the number to calculate the factorial. See, Enter the number to calculate the factorial. Scan it first and enter the number here. Then I equals to n means initially I is equals to your entered number. Suppose it is 5. I equals to 5. 5 is greater than 0. Yes, true. So go inside the loop and decrement I value. Okay, 5 minus minus. Okay, so fact into I. So what is I value? 5. What is fact value? Fact value is initially 1. So 1 into 5 is 5. So what will be the output of fact now? In a first iteration, 5. Okay. So again go to this. Okay. I equals to 4. 4 is greater than 0. Yes, true. 4 is decremental. 4 minus minus. Okay. So again, fact. What is the current value of fact? 5. 5 into 4. So 5 into 4 is 20. So now new value of fact is 20. Again go and I value is here 3. 3 is greater than 0. Yes. So again go here. Fact value is 20. 20 into 3 is 60. Then again go. I equals to 2. 2 is here. 60 into 2 is 120. Fact value is 120. Again go here. I is 1. 1 is greater than equals to 0. Yes. Go here into 1. This 120 into 1 is 120. Again go here. I equals to 0. But 0 is greater than 0. No, false. So jump out from this loop and print here factorial of number is. Factorial of number is 120. Okay. In this way you can calculate the factorial of number. You can try the more examples of for loop to understand better this for loop. Also trace the for loop on paper. First try this and then try to do the new programs. Thank you. Thank you very much.